Digital logic circuit second unit, combinational logic circuits. So EE8351. So digital logic circuits unit 2. So for second year triple E students. So first one is combinational logic. So so multiple inputs, combinational logic circuits, and one or more outputs. So, what is combinational logic circuits? Combinational logic circuits are individual logic uh, gates only it will be represented. So, the output depends upon the present input. That is called as combinational logic circuit. So, it only responds with the current input. So it won't doesn't have any memory or a delay or something. So that we will see in third unit. So here the example for combination logic circuit is multiplexer, demultiplexer, encoder, decoder, full adder, half adder. So everything is example for combination logic circuits. So this is a output function of combination logic circuit. Output is equal to F is equal to input. And classification of combination logic circuits. So there are three category. One is arithmetic logic function and data transmission and code converters. So under the arithmetic logic function, again they split it into adder, subtractor, comparators, and program logic device. So adders means we know that half adder, full adder, subtractor, half subtractor, full subtractor, comparator. So 1 bit comparator, 2 bit comparator, 4 bit comparator, that we will see later coming videos. And data transmission. So under the data transmission is classified into multiplexer, demultiplexer, encoder, decoder. So multiplexer and demultiplexer, encoder and decoders. So we know what is multiplexer. So multiplexer, it's a many datas, many several datas that will be converted as a are sent as a single transmission line. That is multiplexer. Demultiplexer, one input and many several sources of output. That is demultiplexer. And encoders and decoders. So encoder is 2 power n input and n output lines. So similarly, decoder is similar like a demultiplexer. The only thing is there is no data input. So demultiplexer having n input line and a 2 power n is output lines. That we will see discussing later. And finally, code converter. So binary to gray, gray to binary, and BCD to 7 segment. So these are the things as a code converter. So that is also we discussed in coming videos. So these are the example for combination logic circuits. So representation of logic function. So there are three main way they can easily to represent the combination logic circuit. One is Boolean algebra, another one is truth table, and third one is logic diagram. So in Boolean algebra, we know that it shows the expression whether the result is true or false. See, so this is a true logic representation of Boolean algebra. And then truth table is defines the function of logics. So what is the gate input output? So everything the operation will be written in the table. A logic diagram, it's a graphical representation of circuit. So that logic diagram has AND gate, OR gate, XOR gate. They will be implemented using logic circuits. So this is Boolean expression. So example for Boolean expression here they given Q is equal to A dot whole bar dot A plus BC bracket dot C. So whole here also bar they given. So this is bar Boolean expression example and truth table and then logic diagram. So logic diagram means logic gates. So it's a graphical representation. Input they given the data input and the gates. Here the this is NAND gate. This one is NOR gate because of bool, and this is AND gate and this is the output. And truth table for this, so this is truth table, that means this is the input and q is output. So it will be expressed that operation of the logic diagram. So this is a three-way that logic circuits representations are given. Okay. So this is simple briefly explain about combination logic circuits. Thank you.